derive expression for acceleration of an object sliding down on an inclined plane. This is a question. This is inclined plane, angle of inclination, this is object, and it is sliding down with this acceleration. We have to derive expression for this acceleration. Expression for acceleration of an object sliding down an inclined plane. Let A acceleration of object sliding down theta, angle of inclination weight always act downward, perpendicular to ground. This is ground. Normal reaction always perpendicular to surfaces in contact. So this will be theta, this will be mg cos theta, this will be mg sin theta. Resolve mg towards theta, it will be mg cos theta, perpendicular it will be mg sin theta. It is sliding down, then this will be direction of force of friction. Again, A is acceleration. If it is moving down, this is what force of friction, weight perpendicular to ground. It is resolved as m cos theta, and this is what? Normal reaction. Let mu, coefficient of friction, R, normal reaction, F, force of friction. Now downward for m is mass of object. Downward force is ma. Why? A is acceleration, m is mass, the force is ma. According to figure, net force in downward direction, mg sin theta is in downward direction, F in opposite, take F in this direction. Ma is this is ma, this is a net downward force here according to figure, or it is ma it is mg sin theta mu r. Why? Mu is F by R. Coefficient of friction is this. Ma mg sin theta minus mu r. Mu, what is r? This is r, opposite mg cos theta. R is mg cos theta. Mg cos theta. M is common, cancels out. G also common. Sin theta mu cos theta. M goes with M. A is G sin theta minus mu cos theta. This is what acceleration of an object sliding down on an inclined plane. Work done. Next question. Against friction on level, rough surface. This is a question. This is ground, rough surface, this is object, and this is motion of object. So this will be what? Force of friction. It will act in opposite direction. Let this will be what? Displacement. Because we know work Fs, force into displacement. Let S displacement, mu coefficient of friction, R normal reaction, F force of friction. We know work done, that is W, force into displacement. Or W, force. According to figure, this is net force in forward direction. Only force of fraction is in reverse direction, so this is force. F mu R S mu F by R. Now here it is what? Weight. Here it is what? Normal reaction. Minus mu R. R is what? Mg S. R is mg. So this is work done against friction on level. Derive expression for work done. By an object moving down on a rough inclined plane. This is rough inclined plane. This is object and this is motion. This is theta. Weight always act downward, perpendicular to ground. Normal reaction always perpendicular to surfaces in contact. So this angle will be theta. Resolve mg. Mg cos theta. It will be mg sin theta. And this is what force of friction. Again look, this object is moving down. Weight perpendicular to ground. Normal reaction perpendicular to surfaces in contact. So this, resolve this towards theta, mg cos theta, perpendicular it is mg sin theta. Let m mass of object theta, angle of inclination mu, coefficient of friction R, normal reaction S, displacement. Work done is what? Force into displacement. So we want to find force in downward direction. Force in downward direction. See figure. Mg sin theta is in downward direction. This is mg sin theta, this is force of friction. Minus F, this is net force in downward direction according to figure. This is mg sin theta, this is downward, it is this. Say this is small f. Small f. Mg sin theta, f is mu r. Why? We know mu, f by r. Mg sin theta minus mu r. This is r. Newton's third law. This equal to this. R is what? mg cos theta. कहाँ से फिगर देखिए? R mg cos theta. M common, G common. It is sin theta minus mu cos theta. Hence, work done. That is W. small f is that force. And what is small f? mg sine theta minus mu cos theta into s. This is work done. Find coefficient of friction when acceleration of object moving down on an inclined plane of 30 degree is g by 4. This is a question. Find coefficient of friction this is object, this is theta, this will be weight, this is what? Normal reaction. This will also be theta. Resolve this mg. Mg cos theta. Here it will be what? Mg sin theta. Here is what? Force of friction. We know downward force, if A is acceleration, is what? Mg sin theta minus F. Mg sin theta, F is mu r. Mg sin theta mu r is mg cos theta. M goes with M. So A is g sin theta mu cos theta. Already calculated the A. Here A is g by 4. Theta is 30 degree. So g by 4 g sin 30 mu cos 30. G goes with G, 1 by 4. It is 1 by 2. It is mu root 3 by 2. Take mu this side. Mu root 3 by 2 is 1 by 2 minus 1 by 4. Or it is mu it comes out to be what? 1 by 4. 1 by 4 2 root 3. It is 1 by 2 multiply by what? Root 3 divide by root 3. So it is what? 1.732 by 6. Nearly this. This is what? Coefficient of friction. Derive maximum acceleration of train so that box lying on its floor remains stationary. This is a train. This is motion. So this will be, this is box. This is action on box. This will be reaction. So box will move in opposite direction. So there is what? Force of friction. This is motion of train in this direction towards the left hand side. The box is in train. So this is action on the block. So for every action there is reaction. This reaction is in this direction. So in this direction there is what? Force of friction. So this is what? Weight, and this is what? Normal reaction. So M, mass of box. F, force of friction. Mu, coefficient of friction. R, normal reaction. If this is the reaction, this will be the force. If A is acceleration of block, the force is ma, and it remains stationary, so these forces are equal and opposite. And R is mg. Dividing first by second, F by R is ma mg, or F by R A by G, or F by R is mu Ag, A by G. So A is mu G. So this should be maximum acceleration of train, so that box lying on it remains stationary. A box is lying on inclined plane of angle 30 degree, remains stationary. Find expression for coefficient of friction. Another problem. This is the box. This is inclined plane. So here what is this? Weight. This is normal reaction. This angle will be theta. This is what? mg cos theta. This is mg sin theta. And this is what? Force of friction. As box is stationary, so F is mg sin theta. This will balance this. And R mg cos theta. Dividing first by second, F by R, mg sin theta, mg cos theta, mg goes with mg, it is tan theta. Or mu is tan theta. Why? Mu is F by R. It is tan 30. It is 1 by root 3. Or it is root 3 by 3. 732 by 3. This is what expression for coefficient or simply coefficient. Derive expression for work done. By object moving up on an inclined plane. This is a question. This is inclined plane. This is object. This is angle of inclination. Weight always act perpendicular to ground. Normal reaction always act perpendicular to surfaces in contact. This angle will be theta. So this will be resolve mg cos theta towards theta, and it is mg sin theta. This is motion of block, motion. So this will be direction of force of friction. A upward motion is there, so force of friction will act downward. Let mass of object mu, coefficient of friction F, force of friction R, normal reaction theta, angle of inclined plane, then net force in upward direction, that is small f. This force is in downward direction. In upward, the force is minus F plus mg sin theta. Because this force is in downward direction, so force in upward will be this. F is mu r. Mu F by r. Mu is mu r. This is r. This is in opposite mg cos theta. R is mg cos theta plus mg sin theta, because R is mg cos theta. M common, G common, minus is there, mu cos theta plus sin theta. Let S displacement, hence work done, that is W. It is small fs. Small f is this one, minus mg mu cos theta plus sin theta into S. So this is work done against friction. This work done is why a cyclist bends on circular road. Find angle of bending of cyclist and maximum velocity. This is a question. When there is circular path, road, the cyclists have to bend. Why he bends? Cyclist bends to provide necessary centripetal force. Otherwise, he will fall down. When anything want to move in circle, centripetal force is necessary. So he bends to provide the necessary centripetal force. This is that circular path. This is radius of that circular path. This is normal. This is that cyclist. He bends at angle say theta. This is center of gravity. CG. So this is weight acting परपेंडिकुलर टू ग्राउंड. नॉर्मल के पैरेलल खींच दीजिए. ये साइकिल सपोज कर लो स्ट्रेट है तो नॉर्मल रिएक्शन स्ट्रेट ही होता, नॉर्मल की तरफ ही होता. नाउ दिस इज नाउ नॉर्मल रिएक्शन. सो दिस एंगल विल ऑल्सो बी थीटा. दिस इज r cos theta. And this will be what? R sin theta. Resolve R towards theta. Let theta angle of bending R radius of circular path, road, whatever may be, M mass of cycle plus cyclist. R is normal reaction. Mu coefficient of friction. Here R cos theta is mg. R cos theta is balanced by weight. So R cos theta is mg. This R is resolved. It is finished, resolved. Now this is equal to this. Only this is free and it is towards center. Now R sin theta is free to provide the necessary centripetal force. Why? R sin theta is towards center, and the centripetal acceleration we have already done towards center, so centripetal force towards center. Therefore, R sin theta is mv square by r. This v square by r was centripetal acceleration. F is ma. F ma. So ma dividing second by first r sin theta r again this is r cos theta. This is what? R cos theta mv square by r or by mg, or it is what? Tan theta v square by rg. It is third, or theta tan inverse v square by rg. This is what? Angle of bending of cycle on circular road, circular path. From third, v square is what? Rg tan theta, or v Rg tan theta root. Or v can be Rg mu root 6. We know this thing. Mu is what? Tan theta, already done. So this is why cyclist bends and find angle of derive expression for maximum velocity of vehicle on level circular rough road. This is the rough road. This is radius. This is a vehicle. This is front of vehicle, tires. What are these? Tires. This is a vehicle. This is weight. Plain road, plain, level. This is normal reaction. तो यहाँ क्या होगी? सेंट्रीपिटल फोर्स. Who will provide this force? Force of friction between tires. Let R radius of circular road. M mass of vehicle. V maximum velocity of vehicle. Capital F force of friction between tires and road. From figure R is mg. And force of friction will provide the necessary centripetal force. If there is no centripetal force, then vehicle will overturn. So what is force here? Tires and road. This is what? Force of friction. So F is centripetal force mv square by r. V square by r centripetal acceleration we have done. Force is ma. Dividing second by first. F by r mv square by r by mg. M goes with this m. F by r is v square by rg. And F by R is mu, V square Rg. Why? Mu is F by R, coefficient of friction mu. Mu is what? It is coefficient of friction. So V square by Rg. So V square mu Rg or V mu Rg root. So this is velocity of vehicle on level rough circular road. What is banking? Why it is done? Find maximum velocity on rough bank circular road. Hence find it on smooth road. Erasing of road from outer edge called banking. It is done to provide the necessary centripetal force otherwise vehicle will overturn. So this is what banking, lifting, raising of road from outer edge. It is done to provide the necessary centripetal force because when a body is moving in circles, circular centripetal force is necessary. This is that circular road. This is banking. This is angle of banking. This is radius. This is vehicle. ये front, vehicle का front. Weight always act perpendicular to ground. Normal reaction always perpendicular to surfaces in contact. So this will be theta. Resolve R. It is R cos theta. And perpendicular it is R sin theta. This will be force of friction. This angle also will be theta. So this will be, resolve this F cos theta. And it is F sin theta. This is figure. Again listen, this is angle of bending, this is lifting from outside. ये ऐसे लिफ्ट करती बाहर थीटा. ये फ्रंट है व्हीकल का फ्रंट. ये वेट ऑलवेज परपेंडिकुलर mg. Normal reaction perpendicular to surfaces. So this angle is theta, so this angle will be theta. Resolve R cos theta, R sin theta. This will be force of friction. Vehicle or its surfaces they reach. So this will be F cos theta, and this theta की तरफ F cos, this will be F sin theta. let theta. Angle of banking M. Mass of vehicle F. Force of friction mu. Coefficient of friction R. Radius of circular path road V. Maximum velocity of vehicle according to figure R cos theta is F sin theta plus mg. R cos theta, take this F this side, F sin theta is equal to mg. R cos theta mu r sin theta is mg. Take r cos theta outside. R cos theta 1 mu tan theta mg. This is number first. Again, it finished, resolved. This force of friction resolved, so it is also finished. So figure says this is an upward, this is in downward direction, and F cos theta plus R sin theta it is free to provide the necessary centripetal force. So F cos theta plus R sin theta, centripetal force mv square by r, F mu r cos theta plus R sin theta is mv square by r. R cos theta common, mu plus tan theta is what? mv square by r. This is number second. Dividing second by first. second r cos theta mu plus tan theta by first r cos theta 1 minus mu tan theta by second was mv square by r and in first it was mg. So cos theta with cos theta and with m or v square rg comes out to be mu plus tan theta 1 minus mu tan theta or v square rg mu plus tan theta 1 minus mu tan theta or v rg mu plus tan theta 1 minus mu tan theta. Number is third. So this is what under the root this is velocity of vehicle, maximum velocity of vehicle on rough banked road. Hence, on smooth road, mu 0, putting in third v rg zero plus tan theta by 1 minus 0 under the root or v rg tan theta. Fourth, suppose angle of banking is there inverse